Welcome back. Today's topic is transfer capability and other keywords which are associated with it, which we normally hear in power system transmission sector. We will have a quick review about all these terms today, and we will see at the end how ATC is computed with the help of these different components. Now, I hope that by the end of this lecture you will be able to define all these terms, and I hope that you will be able to explain why maintaining of margins is very important in power systems. So I will start with TTC, the TRM, the CBM, the two margins which we normally employ, followed by at the end I will take this ATC so that we will develop an expression for computing ATC. Now, coming to total transfer capability, as we have seen in the last video lecture about the difference between transfer capability and transmission capacity. See, the big difference between these two is nothing but this is more of a design criteria, where if I design a conductor, so based upon the thermal standards, I do feel that the transmission line is capable of carrying this much amount of power. But that is not true when I employ that conductor in power systems, because I am supposed to think about so many factors when I employ a transmission line. I do have my limits on voltages, power transfer capability, etc. So when it comes to operation, the transmission capacity cannot be employed for transfer of power. I am more concerned about transfer capability, which is a true value of maximum power, which can be transmitted subjected to network constraints. So in power system operation, transfer capability is one term which is commonly employed rather than transmission capacity. Strictly speaking, it is defined as the amount of electric power that can be transferred from one area to another over the interconnected transmission network in a reliable manner based upon pre-contingency and post-contingency conditions. So these transfer capabilities will be varying depending upon the network parameters and network condition. So based upon the pre-contingency and post-contingency conditions, what is the maximum amount of power which you can transfer is called as total transfer capability. Total transfer capability. Normally, as already said, transmission capacity is limited by thermal limits. Transfer capability is always less than transmission capacity. See, this is always less than transmission capacity. Apart from this thermal limits, there are other limits also which you need to consider. So the normal limits which we consider in power systems, which you might have studied in the previous courses, are one is thermal limit. This is transmission capacity, and the voltage magnitude limits. The voltage limits at the two ends of transmission lines, and the stability limits. In the stability limit, we do have different types of stability limits. We know that it is voltage stability limit, transient angle stability limits, dynamic angle stability limits. So all these types of angles, torque angles will be there. So TTC is normally constrained by all these limits. Having said this, let us suppose if I do have three limits: thermal limit, voltage limit, and stability limits. TTC is obtained with the minimum of these three limits. Whatever the minimum value among all these three, that will be your actual TTC. And the constraining condition of the transmission network would shift among the three limits as operating conditions change over time. Because the voltage limits and stability limits, they do vary with respect to time and with respect to network conditions. So that's why TTC also will be varying all the time. And TTC, since I already told you, these will be varying from time to time. TTC will be computed hourly, daily and monthly based upon the market requirements. And these will be defined for a pair of areas, that is a power selling area and a power buying area. Let us suppose if I do have this generator is available here and this is a load is available. So normally TTC is defined for this entire area from 1 to 2. What is a TTC? This is the way how we determine the TTC. So the next thing is this is an illustration of how TTC will be computed. If you carefully see, with respect to time, this is a stability limit, the single loaded line. This is a thermal limit which doesn't vary with respect to time. It is basically designed when you design a particular transmission line. Voltage limits will be varying with respect to time depending upon the network conditions. So whatever the minimum value among all these three will be chosen as a TTC. See, in this case, this is the minimum value, and here this is the minimum value, here this is the minimum value, and this is and this is. So this is the way how TTC will be computed in modern power systems. Once you do have this TTC, now let's have a look at the factors which are to be considered in calculation of TTC. The major factors are, the number one is the list of contingencies, because most of the times in power systems we do experience severe disturbances, and during disturbances we do have a sudden disruption of services, maybe transmission, maybe generation, maybe loads. So this is one thing which is to be considered when you are calculating TTC. The other thing is accuracy of the load forecast, because every time you decide about the transmission capacity based upon the loads, available loads. So you need to properly forecast the loads and the unit commitments, which is on the generation side. Apart from this, the maintenance scheduling. This is also to be considered when you are computing the TTC. So these factors play an important role in determination of TTC. Apart from this, there are other devices also which you need to consider, because you do have this voltage stability also. Sometimes power system stability and voltage stability can be improved by using some external devices. Some such devices are voltage regulators, reactive power control devices. These also, they will directly affect this voltage stability and voltage limits and stability limits. So these should also be considered when you are calculating the TTC. Moving on to the margins now. As already said, whenever you are computing TTC, let us suppose if TTC is obtained as 300 megawatts and already there is a 150 megawatts load which is being carried out on this transmission line, you can't state that 150 megawatts remaining can be ATC, because ATC should be taken into consideration. ATC should be calculated after considering some margins, because as said yesterday, there must be some margins which must be kept aside to deal with some unwanted conditions. In the yesterday's class, we have discussed that there will be some unwanted conditions, just like congestion, or maybe because of the weather conditions, there can be some problems in the transmission capacity, and there may be problems in the generation capacity also. So to include those abnormalities, we should keep aside some portion of this transmission sector as margin. There are two important margins which are generally considered in power systems. One such one is a transmission reliability margin. So a transmission reliability margin is generally referred as TRM. This is generally included to address one particular uncertainty, and as defined by the FERC, it is the amount of transfer capability which is necessary to provide a reasonable level of assurance that the interconnected transmission network will be secure. So any uncertainty in model parameters, just like line impedance, etc., or load forecasting errors may be happening. So to address these things, some part of transmission capacity, transfer capability is set aside. So in the TTC, so 10% will be always, or this is not exactly 10%, some margin will be kept aside for addressing these uncertainty issues. So what type of uncertainties can you expect in transmission sector? See, there may be load forecasting error or load distribution errors, they may be happening, or sometimes there will be variation in facility loadings when you are balancing the load in generation. And there may be uncertainties in forecasting the system topology, and there may be some sort of loop flows, simultaneous interactions, or generation dispatch due to component outages, and there can be sometimes short-term operator responses also. So all these things to be included when you are computing TRM, which means how much percentage of TTC you should keep aside as a margin. So this is transmission reliability margin. The other margin is capacity benefit margin, which we call it as a CBM. This is a second margin which is generally included in TTC. CBM is the translation of generator reserve margin, because sometimes what happens in power systems is that the generation may not be able to meet the demand. Suddenly the demand may get spiked, so you should rush in to balance your power system. In that case, what the people will do, the independent system operator, he tries to maintain some sort of reserve. And to maintain this reserve, you should keep some transfer capability separate, such that if there is a sudden rise in demand, that should be addressed. So CBM is a translation of generator reserve margin into a transfer capability quantity, which is normally determined by LSEs. LSEs are those entities which are basically, they are buyers, but they are responsible for providing power to the lower level entities, just like customers, direct customers or retail customers. So these will be discoms. They will be providing capacity or ancillary services to retail customers within a host transmission provider. So a CBM is just like a reserve capacity equivalent in terms of transmission capacity. And it is a responsibility of transmission provider to maintain this CBM. So he determines how much CBM is to be kept aside by considering all the requirements of transmission customers entitled to a portion of CBM. So as defined by FERC, it is the amount of firm transfer capability reserved for load serving entities on a host transmission system where their load is located to enable the access to generation from interconnected systems to meet generation reliability requirements. So this is the definition of CBM as defined by FERC. And the amount of TTC which is preserved for CBM for a particular load serving entity, it allows that entity to reduce its installed generation capacity below what may otherwise have been necessary without interconnections to meet its generation reliability requirements. And the transmission capacity preserved of CBM is intended to be used by LSE only in times of emergency generation deficiencies. So beneficiaries of CBM are the LSEs of a host transmission provider, and each LSE would have a reduced need for installed generation capacity. This we will discuss in detail in the class. Now, having discussed about the TTC, CBM and TRM, now we will move on to our available transfer capability. This is what we are focused on. The definition of available transfer capability is the measure of transfer capability which is remaining in the physical transmission network for further commercial activity over and above already committed uses. So it is an indication of the expected transfer capability which is available still on the transmission network. It is a market signal that refers to the capability of a system to transport or deliver energy above that which is already in use. So this ATC is very much important in modern electricity markets because they are employed in determining the transmission service components. So technically speaking, ATC is TTC minus the margins, whatever the margins. First of all, you will reduce the transmission reliability margin. Apart from this, the existing transmission commitments plus the capacity benefit margin. These will be summed up and they also should be reduced from this TTC. So this is the final expression for ATC. So I hope that now you are able to define this ATC, TTC, TRM, CBM, etc. The different components which are generally encountered in power system, power markets. And I hope that now you are able to explain why maintaining of margins is important in power systems. And these are the references. Thank you. In the next class, we will see problems on these ATC.